Hello, hello, hello. Welcome, welcome. Of course, I didn't prepare anything on the second monitor again, as usual, but alright, so yeah, yesterday we were we finished the octree. I mean, more or less. We have one more step, which is the smarter subdivision. So basically this is the complex surface, which is fine. And now we need to check if bool has geometric error. Let's open the C++ version. The original, so we will try it with that. The original cubical marching squares uses a different heuristic for the subdivision, which I'm not sure if it makes sense. So what the original one does, it basically marches along the edge and checks if there is more than one intersection on the edge. What that basically does is yeah, it basically wants to subdivide if there is two crossings on the same edge, because then there might be some ambiguity that we don't really want, like can't really handle too well. Center. Do we need more? Oh no, actually that's enough. And now we basically can take all of those. We will put that here as well, because why not? And then all of those are floats. So that is fine, and all of those are W's. Now we have the const float, well, vec3 from is corner at 0, and const vec3 2 is corner at 7, in my opinion. I'm not sure why it would be otherwise. I mean, okay, I mean, here we put it like that, but I don't think that is correct. I mean, it doesn't really matter, I think. Well, I mean, technically it does matter, like quite a lot, but so corners. Well, I mean, yeah, let's do corner 0 here. Then we do this. Is that Oh, we do it in the header? Yeah, we do actually. But I copied the same one. God damn it. Why would I do that? Oh, great. That starts again. Beautiful headset on and off sound. Then we have corner 6 here. 1, 2, 3, 4, 5, 6, 7, 8. Wait, that doesn't sound right. This is duplicate. One, 2, 3, 4, 5, 6, 7. Still a bit sus. Oh well. Okay, no, if I didn't clear that one, it's fine, right? Which I didn't, and then corner 7 here. Because that one is... yeah, it's the same as here. Perfect. Okay, so we can get rid of that. Alright, so first we check that one, and then we check if we have an geometric error with our position, our corners, and our corner samples. And if we do, we return. Otherwise, we return just the octree node as is, right? And basically set it as a leaf. Well, actually, we set it as nothing. No, actually, I think we set it as a leaf, right? What did we do in here? Oh yeah, we set it as a leaf, yeah. So that's a leaf. But I mean, technically, we don't need to do anything like that, right? That leaf mask is a little bit sus, but yeah, let's put that leaf mask there like that. That is not correct. Oh yeah, no, that is correct. We add children like that. I mean, the leaf mask is kinda useless right now, the way I'm using it. So I'm not sure. Hey, GD Bobby. Hello, hello, hello. So that is a bit problematic. Should probably mark that somewhere. Leaf mask and valid mask are kind of sus right now. Because as I said, they don't really... Because realistically I would have to set that at the parent, which I can't right now. I mean, this is fine, right? That is fine. But realistically, I would need to know... The leaf mask, I think I have to set in a separate step afterwards. Because I have no idea if this is a leaf or not at this point. So yeah. That is a little bit problematic. So we have to... I don't think it matters for now. But it will matter in the long term, so we will definitely have to come back to that. So we have the has geometric error, which is here, which we did here already, this part, but we need more. I will put that on the second monitor, the C++ version. We have that, and then we basically construct a couple of const vec3s from that, center, back, bottom is our center at 0, our from at 1, and our from at like that. I mean, we can probably just move them here and adjust it a little bit. Spec 3. 3. Huh? How did I manage that? Oh. I mean, the question is, do we even want to do it like that? Probably not, actually. We probably want to do const vec 3. Sample positions. Vec 3 of 19. Y2? Oh, okay, because what is it used for? Here for the interpolation or what? Okay. So let's do 19 and 2. Basically this. And this. Now this center back bottom. And we put comments like that because then it's easier to understand what it is. Let's bring those over. Center left bottom. Center bottom. Center right bottom. And center front top. Alright. So then the only thing we need to do is basically bring and all of that we should replace with vec3 and then center left bottom center bottom center right bottom that's the C++ version, right? Let me open it. I guess. Oh no, I had it on the second monitor. God damn it. Wait, let me bring it over. So my vector is templated, right? So the scalar is basically the numeric value, like the scalar of the vector, like if it's an int vector, a float vector, or whatnot. God damn it, what am I pressing? Vector. Where is it? I'm fat fingering pretty hard. So yeah. Basically it's just like what data type is inside the vector. And in this case the C++ version supports, where is it? Cubical margin squares. Oh, it's here, right? It supports different like vector types here. Which in reality it doesn't really do because it's float here, so yeah, it's a little bit. But in theory it would support other vector types, but in reality it's not really well implemented. But that's mostly because this, I think, in the past was hard-coded to a vector 3f, but then the vector class changed to be a template and I never adjusted this one. So yeah. Center left. Wait, and then we had a split here. Center right. Center front left. Center front. Center front right. You never seen that or what? I mean, it's, I would say, not so uncommon to have that templated. Because you can support then any type with the, like any scalar type with your vector, right? And on this node center here, we don't have. Oh no, we do. We do. It's just this, right? Basically a node center with center. All right. And we bring over the last puzzle piece, which is basically that part. Which in here, in this case again, is a float here. And we have vec 4 and vec 3. Oh yeah, it is. It is. It is. This goes away. This becomes just a uint. Sample positions. That and that. This is get sample value, which gives us a vec 4, which gives us the gradient. Do we do anything with the gradient? Oh, we do. Now we absolute the value dot the w minus the interpolated. We add it together. We have a max geometric arrow, which we need to define up here as well. Which I have no idea what's a good value anymore. So we will have to trial and error that a little bit. Which at this point maybe we should re-evaluate a little bit. And here return true, return false. Do we have space in our U? Oh, we do actually. U, like float max geometric error and float max complex surface threshold. that, and then we can do here U constants, complex surface threshold. Here we can do U constants, max geometric error, and then we can already control it from outside, which is good. And all of that is nice. Then we need to only do the int bullet, which I don't have. That one is as well quite easy. That was a mistake. So it's this. The scalar we replace with float. That is a vec3. X, Y, Z, X, Y, Z, Y. All right. Can get rid of that then. And we need to go to C++ here. Float max geometric error and float complex surface threshold. Max geometric error. So who will take bets? I did a shader mistake. I am thinking I did. Pretty sure I did. Of course. I mean, that would have been the worst, first 140. 140. Oh, well, yeah, makes sense. Corner samples. Is that even already to get sample value? Is it already? No, it's not. So that needs to be a vec4. Which we need to basically do. So in the simplex noise source, get internal value. That's just a gradient or what? But is that correct? I mean, I guess it might be. I mean, we can look at that later, but for now, let's just return the gradient as is. So basically a vec4 of noise gradient xyz. But that's the plane normal, and what do we do with that? I mean, I guess it's just norm plus plane normal. That should maybe work. I don't know. I think that is equivalent to the other part. So that's vec4 here now. And I think that's fine. Let's see. Yeah, of course. 259. I mean, we're already quite far down, I think. 259. Never mind. I think we will still be a long time on this, not just because child extends. Oh, isn't that half extend? Is that half extends? Is that half extends or extends? Or this is the center position. This is already a half. So it should be it should be extends, right? Right. Yeah, exactly, because this is half extent, but the half extent, yeah, that should work because we half it by multiplying here with 0.5, right? Basically, we get to the half extent then. Should work. Oh shit, wrong one. 263 distance to surface. Or did we not do that? Did I not do a sample here? Oh, yeah, I didn't. Vec. Well, vec for sample. and this can be optimized quite a lot. Everything here. I mean, not everything, but a lot. 271, wrong vector size. Does he maybe not like this? So we probably have to do it like that, maybe? Does that work? That worked. Okay. We didn't have an error here. Let's see what that did to render doc. If we have more or less leaves and more or less children. Resource. Where is my... Oh, it's in here, right? So that's you and... Oh, that's a struct. Well, actually, no, it's like you in count, then you in 64 T nodes, right? Ah. That's 200,000 less nodes. So that definitely did something. Because yesterday we had 700,000. So that definitely cut out some nodes. Let's see how we are on the leaf nodes. So that's you and that is leaf node array, and that one is a struct. Of you in 64T, Morton, you and offset. I mean, that's still quite a lot of leaves. But let's see. Let's give it to the meshing and see what happens, I guess. Oh wait, is it offset or is that depth? I think that is actually depth, right? Isn't it? I think, yeah, it's depth, but still. Yeah, I mean, it is what it is. I think there is a lot of nodes that we don't really need here. Because currently, if we... Hold on, so if we... Right, where is it? God damn it. Ah, here. So if the half distance less. This is basically if our not yet, but we have a valid octree. So I was about to add first try to triangulate it. But yeah, I mean, we can try it. So what we need to do for that is change this one to leaf node, where we get a U and 64T Morton, and we get a U and depth. Now we get this octree active leaf, well, octree leaf nodes. That would be horribly going wrong, I will tell you that much. So that one goes in here, that's leaf. Yes. Yes, yes, yes. So we don't do that. We basically go here as well, 64 in like one direction. And we get a U and flat index X. That one goes away. Not sure how I handle that yet. Oh well, we don't actually need that. Hold on, we don't need that. That's like the benefit of that. So we get our flat index, then we get our leaf node is U constants octree leaf nodes, well, octree leaves at flat index. If our flat index is greater or equals to U constants. Yeah, so this here has to count as well, right? What we forgot. We should move those things to a common header so that we don't make that mistake, but yeah. can move all of that down here. We don't need to do any of that. We can actually do it similar to what we do down there in the other shader. Do it like that. And so we get the leaf. And that has a Morton and a depth. So what we do is we build our depth mask out of that. Like that. So that is leaf depth. Well, yeah, leaf depth. Like that. Then this is leaf.Morton. That one we don't need. That is then our coordinate. Node center. Or leaves. Like leaf center. Oh, okay, sorry. Leaf coordinate. That is then the vector leaf center. The node extents we need to calculate as well, which is this. Float node extents is u constants root size divided by a float, which is this leaf.depth. And then we have this here, and then we have our leaf center position, and we have our node extents, which is everything we need to construct the rest. So basically this then is our leaf center plus yeah, basically the same thing that we do here. Where is it? Oh my god. Where is it? Here. This. Corners. And that is minus like that. And that is all the way like that. So now we can get rid of that. And then we have 8 samples here, which again we can copy. And yeah, we are doing it 2 times now, but it simplifies the logic quite a lot, and the storage is way simpler. Because we don't need to care about storing the actual data of the voxels. But let's see if that is a performance problem. We will find that out now, right? Because we are basically sampling the function 2 times. But I mean, that's only during generation, so it might not be a problem. So I think I can get rid of all of that. Now we call generate mesh with the corner samples and the corners. I mean, maybe. Maybe. We need this one. Let's reuse this one for this case. So what we need is the leaf count stuff. We just do a 1, 1, 1. We get rid of that basically. Just have an octree leaf. Like that. And we have an indirect dispatch buffer. And this is all basically empty. This is really just indirect value constants. Indirect dispatch. Dispatch X is our U constants octree leaf nodes count divided by 64. That's all it is. That is basically just kicking off the and let's seal that, because even if we do 1, it doesn't matter. We do 1 so much, but we definitely need to trigger all of them, right? And then let's add those shaders here. Basically init mesh or kick off. Init generate mesh dispatch shader and generate mesh shader. Fill generation mesh dispatch. Init volume. Extract mesh. Or let's do ISO surface extraction. Why not? That is generate volume. Alright, so then we do all of that. At the end, we are done with that. And we do another compute period just to be sure. And then we do compute command buffer bind shade effect. Dispatch 111. We need the push constants for that as well. But yeah, and then we do this and we bind the generate mesh shader with dispatch indirect, the indirect. We can actually reuse the indirect dispatch buffer here. Init ISO surface extraction. And that is a U64 leaves buffer and indirect dispatch buffer. Init ISO surface constants. Okay. Now we have to generate mesh pass. Which I think this is empty, right? We don't push that currently, hopefully. Yeah. We can take those consts here. And that is what do we have here? The raw command index. Transform, which we don't really need anymore. So we can do it like that, and then we have here well, a float root size. I can do float root half extends, why not? We can give it both. Where is the draw command? Oh, here. Yeah, that should all be fine, I think. I mean, we definitely did a mistake somewhere. I'm pretty sure. So that would be basically like that. So what I want is the leaves buffer, the vertex buffer, and Onyx U64 vertex buffer count, or vertex count buffer, and U64 indirect draw buffer, and then float root size and float root half extends. That is terrain. We don't have... I mean, I guess... we could add it here. Because we need that anyways, right? Vertex buffer is as where terrain runtime, vertex buffer, this is surface context, vertex count buffer. So we have those four, then root size is... don't we have it here? Oh, we have it here. Basically this, this, and a mesh vertex, or the vertex count here. Do we not need that? How was that handled before? No, we definitely need that. Or actually we might not. Because we accumulate that in the draw oh, okay, then we cannot use the draw command bar for the same. Okay. Oh well, we are not planning to anyways. But then we need to change this a bit. We can make that smaller, right? Let's just start. And that one, or this one goes away. Let's just start. Probably fine. Probably fine. Runtime. I mean, that is basically garbage. Let's get rid of that. An indirect draw buffer. This right. Get this what I want. Terrain runtime. SSPO mesh buffer here. That's not optimal currently, but let's see what we will get. Because we draw everything in like one big mesh, which is probably quite stupid. I don't know how many vertices we get. That's like 3. That's too much, right? Is that 6 million? Unshifted by 18. Huh? Oh, okay. Well, it's the whole thing here. Okay. Just this for now. Okay, yeah, so that should be 20, something like that. So that's 1 million, and then that still fits in a size like that, right? Yeah. Let's see if that works. Probably we have some shader problems anyways now. But yeah, we probably have to revive. What did I do? Revive the logic of chunks, because that doesn't really scale, I think. But let's see what we get. Nah, it won't. I mean, I doubt it. I think we will probably run into a shader crash again. As soon as it runs. 15 unexpected. Oh wait, is it that? Yeah, I think I know what it is. Forgot to put some defines up here, which we should probably move to the general area. And then let's just to be sure, terrain panel. Let's kill that again. So basically, yeah, let's comment that out again. Was that one too little? No, actually that's fine, right? Why would you not be happy with that? Oh, okay. Did like that. Hey? Okay, well. Then it's like that, I guess. Alright, I fixed it. I think that should be it, that this was just missing, right? So that it knows what a U in 64 is. Don't say that. It will work, right? It will work. Init volume 44? How? Why? Why would that be? Okay. Seal returns. Would that be? I have no idea why that would be an int float, but okay. I mean, you're very, very confident. I am not so confident. What the hell? But I'm using the same here, right? Seal. Oh, okay. Do I need to... Why is that even in parentheses? What? That didn't make any sense. Alright, so let's then do it like that. So we go in our init here, 0.f. And then we seal that and we call. So that should be hopefully better. Good. 17. What did I forget? Huh? Unexpected identifier. But, oh, did I not save or what? Maybe I didn't save? Oh, I didn't save, okay. 89. 89. Oh. Leaves. Maybe that magically fixes the issues that we have on the 4070s, which I doubt, but decode. Oh, yes, you are right. Decode Morton, you are allowed to not know that. random position. Ah, this one. So that is leaf center, right? And this is node extends. Why is that not aligned anymore? Ah, because this is not correct. Beautiful. What could possibly go wrong, right? So if my stream dies, I will be back. Good chance that it dies once it runs. Oh yeah, we don't have that get sample stuff. I mean, we have a different function here, right? Which is... Ah, where do I have... Ah, we don't have it, right? Because we had it here and we don't. So let's bring the get sample value over for now. We need those two as well. All right. We didn't crash. We crashed now. Because... Oh, generate mesh shader is gone. Did I not? How did I do an oopsie? Yeah, of course I did an oopsie. We didn't crash. That's a good sign. We're not rendering yet because we killed the rendering. Where was that volume system? Here, right? So if we have a volume terrain component, we go in here. And I think we don't do that. Just in place a new draw core. Or here we push a vector 3 F32 0. Oh, it's a matrix 4, okay. It's a matrix 4. And then this is volume terrain, mesh vertices, and volume terrain indirect draw buffer. And draw core material. So now you can bet that it crashes. I mean, could be worse. We see something in the distance. definitely not what I expected. Could be worse. What do you mean what is that? It's beautiful terrain. With some sea in between, like, that's water, right? Imagine some water and everything is fine. It's definitely working. It's definitely... I mean... We have terrain in the distance. Alright. Doesn't work. Let's start render doc. I have an assumption what it might... no, we killed the edit, right? I killed the edit. But we are running with full 60 FPS. I have an assumption what it might be. Although that doesn't look so... That doesn't look... anywhere like I thought it would. Oh wait, maybe... Hold on, two things. Before we give up on everything that I did here. What we definitely need is... this beautiful compute barrier that we already had. Definitely need that in between here. That much is... I mean, we should probably just have a compute barrier on the indirect dispatch buffer, but that's besides the point. I think because the buffer is good enough. And then we need generate mesh paths. We don't do... I mean, I think I still want to do it. So compute command buffer barrier for the terrain mesh vertices to compute and shader right. And then at the end we do one to graphics vertex read. And here we do another one for the indirect draw buffer, where we do a shader right, and then we do another one here, graphics terrain random indirect draw indirect read. Is it from noise? No, I don't think so. I have no idea what is going on, why it's not like working, to be honest. But we will find out, I guess. The question is how do I debug that, as it's fully on the graphics card. I mean, that's our mesh, right? That looks kind of weird. That's like 600,000 vertices. Yeah, well, I didn't want to create a QR code. It's not what I intended to do. That's as well kind of weird, isn't it? That flycam. Shouldn't the triangles be different sizes? But it seems like they're not. Hmm. Yeah, that is kinda expected. I'm using a noise that has a very, very low value, so we should get something very similar to a plane. Let's actually do that for now. That would simplify it quite a bit. Let's just do a plane for now. So let's remove the noise, because that basically makes it a little bit easier to debug, right? We don't have any difference between well, we just have like a flat gradient, right? We don't have any ups and downs, so we should see a flat plane, which is already better and easier to debug, right? Because we then know for sure that it should be a solid plane. Okay. That's interesting. It died. Why did it die is a good question. Let's remove this part for now. Let's just generate the... Okay, so that works. But I guess we ran out of buffer space or what? But why would you subdivide it so much? Okay. That's a bit weird. Or did I do an oopsie? Yes, I did. It's not what I wanted. I have to remove the init flag, otherwise we run this every frame, which is not what we want. But I mean, that was still nice to see, I guess. I apply no resource inspector. Why would you be rugged? Leave you in 6040 Martin. You in depth. You in count. You will leave leaves. Why are you subdividing so much? That doesn't really make a lot of sense to me. Because that's 2 million leaf nodes. which is insane. Because shouldn't it be pretty flat? Why would we subdivide so much? Dear octree. Wait, is that correct? Is that how I did it? Yeah, that's really how I did it. So I guess that complex surface threshold cures it, right? That makes it so demanding, I would assume. So maybe that is actually not correct what I'm doing here. Let's leave that check out for now. Does that reduce the node count? It should. It should drastically remove a lot of nodes, hopefully. If not, then I am kinda lost. Where we like subdivide like crazy. Oh yeah, we actually, I think we basically killed the subdivision altogether, which is expected for a plane. Depth. You and count leaves. Yep, okay. So in theory, if I do that now, and I mesh that, that should just be a flat plane. Let's bring back the meshing. God damn it. If I would find myself where that was. Oh, here. So yeah, I think my complex surface threshold is not correct. Yep, okay. So and that is now a plane that basically spans for 64 kilometers. You can see it in the distance. It stops. Yeah, you can see it here a little bit. I mean, 64 is like kind of insane, but yeah. I think we can see it. I don't know. Well, it works for the simplest mesh. Can I get to the edge of it? Doesn't seem like I'm getting anywhere close to the edge. Would be nice to know where my position of the camera is. Don't have that yet. But yeah, 64 kilometers is far. Maybe we stop that attempt. Because I don't think I can get to the end. Well. But yeah, the good thing is with the complex threshold killed, you know, that's the most efficient mesh I will ever get for the terrain. Because look at how optimized this is. It's one quad. Well, yeah. But basically it's like one quad. For 64 kilometers. Isn't it beautiful? That's exactly how I would want it. If it's a flat plane, that should be what it is. So yes, it works, but no, it doesn't work. But I'm not quite sure why it doesn't work. Why the complex surface doesn't work. It's drastically overshooting how much vertices it should create. I mean, it looks fine, right? Here. Oh, that's nice. We already have some floating point issues. But that's because the mesh is so big. So we have these floating point imprecisions. Well, that's a future me problem. But yeah, we are so far away from the origin that this basically creeps up, right? Because I think at the origin we will not see that. Oh no, we do. Huh. That's fascinating. Huh. Something in my triplanar shader probably. Oh wait, here it's not that bad. Ah, it's still visible. It's a little bit more subtle, but that one is crazy actually. Okay, well, might be an issue. That would be nice if I would see the vertices. Although it might be because the vertices are so far away, right, that this is the problem. That we see it flickering like that because the vertices are so far away. Which is not really something we will have ever in like a normal use case, but definitely something we should consider. Definitely something I should note down. Floating point imprecision, or like precision issues with flat plane on 64 kilometer terrain. But what I wanted to try now is two things. First of all, I would want to try the correct algorithm for the angle threshold. But regardless of that, let's see what happens when we bring back just the complex surface threshold. That will have let's do here complex, well, the geometric error of 1. Or let's make 2, I don't know. Let's see if that gives us something on the mesh. Okay. I mean, we basically have still a flat. Is it still flat? Do we have some more stuff? The noise was very, very subtle. Okay. How did I break that now? What? Okay, now it's here. Capture. Do we have more? Okay, yeah, it is more. It's just probably too subtle, the noise. Okay, that's not what I wanted. Why would you say this is the mesh? Oh, wait, I mean... That's bizarre. Why do I have a big chunk here and then... some chunks here, but other chunks like there. Alright, something doesn't work, clearly with the leaf node buffer. We can crank up the noise a little bit, just so that how do I do that though? Was this scaling it like this, the thing, to make it bigger? I always forgot how that works. I wonder if it was something like that. Okay, so that is definitely as well sus. Okay, no, actually... I mean, we have something in the distance here. Not sure why it broke near. Just by that change. So yeah, something is definitely not working yet. We have some noise here. It's just not how I imagined it. That's not really how I imagined it. Trying to get my terrain generation to work on a big scale. And hello, welcome to the chat. I mean, there is some stuff in the background, but it's like so small. And there's some sync issue going on because, yeah, we sometimes have it and we sometimes don't have the terrain. Is it not that we do it like this, that we scale the noise? Well, I mean, yes. Because it shouldn't just be a plane in the end. I mean, if it would just be a plane, I don't need any thing like that. Yes, you're right. I mean, that looks better. That looks like it did something. It's just that somehow we killed everything in half of it. It's something I built. Yes. It's a simplex noise on the GPU. So that's not it, or what? So that's not really what the noise would be. Okay, that's weird. Why would it suddenly work every time I change that a little bit? That's bizarre. Simplex noise source. How did that work? So we did scale our noise value by the amplitude and then our gradient as well. Which I think it doesn't really matter because that's just our normals, which, yeah, of course they are now broken, but don't really care about that. Okay, yeah, and that would be the frequency. So doing it right, but it comes out wrong. Let's see the noise function again. Because maybe I'm doing it wrong in that sense as well there. Or was that here, right? Oh yeah, that was... So that is the noise value. So the W is the noise. So that at least is correct. Let's do that 0.5 or something like that. Scale that by 20 or something like that. I don't know. It's really a little bit... I should move this to a common function, so I have to change it only in one place. But we have to go back to evaluating a little bit on a smaller scale what's going on here. Because that doesn't make a whole lot of sense. Because even with that geometric error, that should be good enough. Maybe I should add a debug draw for the octree as well, so that we can see where the octree actually is in terms of nodes. That would most likely help the most right now. Adding a debugger for that. That shouldn't be too difficult to do. But I mean, we have the data for it. But yeah, I think I will call it a day for today. I mean, it's some good progress. We got something running, right? We have the mesh. It's by no means correct. For the plane, we got it working, but that was like the easy part, right? I mean, that was kind of obvious that we would get that. And that's not very amazing that the plane works. 900,000. That looks actually okay, but why is it like that? And yeah, that's bizarre. Let's do something. Let's do something crazy. I will try one more thing. But how do I do that? Without... I think I... God damn it, can I? No, that's actually not so easy to do. Because I would need to position my camera further out. I mean, I guess we can try, so let's get rid... Well, we can still do that. We can do that. That is... Is it min or max for the union? It's max, okay. Plane gradient or sphere gradient. Value and gradient. And we have that, and that is vec3 in 0, 0 and minus let's make 20,000. I don't know. But we scale this to 1,000. It would be some sort of like hill-ish kind of thing in theory. We need include sphere. No, where is it? Or is it too far away? Maybe it's too far away. Maybe I was a bit too enthusiastic with the distance. Let's move it 500 away. Make it 500 big. Or and then let's move it 1,000 away. Ah, it's there, but it's not there. Are we not going up in the direct? Like, are we Where is my sphere? I didn't mean to cut it out. Something is wrong. Where is my sphere? It feels like we're not going up or what, or was it the subtract instead of what? Oh yeah, you're right. I did a subtract. Well, I did an intersection. So yeah, you're right. I did it wrong. That should be a min. And it's gone. Oh wait, it's where? I think I know what it is. Let's do the actual union. Fuck it. Let's include the union. Is it here? Yeah. And then we fix that later, but I think the union, it checks only the gradient, and currently I do a min of the whole thing, which is of course garbage. So we need to basically do, where is it? Oh my god, lost it. Okay, so we add the union here. And then we say union think. Okay, get union. Like that. And okay, we don't have it included here yet. And oh, here we save as well. All right. No, still pretty much the same thing. Just bizarre. It seems like we're not going up in our resolution or something like that. Let's go ham here and let's say 0.1, which is actually the error we kind of want, but that might explode now the mesh. I don't know, maybe we run out of vertex buffer. Okay, no we don't. Fascinating. What does RenderDoc say to that whole thing? I mean, I can kinda imagine what it says, but I'm as well confused by the resolution a little bit. 15,000. Or is a little bit weird. Okay, I mean that is actually pretty nice because that means our octree is kind of working, right? We have like the far chunks in the distance are super huge. So that works. That's a good sign. And the closer we are to the player and to the actual interesting surface, the smaller the things get. But they are still kind of huge. I wonder if it's because of something I tried to be smart and then it actually kind of backfires. Is it? Is it this? But even that doesn't make... Because the position of the camera... I mean, it looks like yeah, maybe that would help as well, right? But I mean, one of those triangles, it's still... What's the size here? In X... Yeah, I mean, that's 100 meters, right? That's like way too much for what I want. That's like 100 units. That's like huge for how close, in my opinion, we are. Is it? Okay, no. 640. $64. Oh, that looks interesting. So it's this. But how come that would be 8,000 units away? Is that really the case? That sounds kind of sus. Let's try something stupid. Does that make it better? Not really. Let's go super stupid. Oh, there it is. It is our killing of the like terrain when we have a distance that's too far away, or what? Huh. So it's my lot thing that kills it? no, that's not what I wanted. Did this? Yeah, toggle comment. Okay, well, it doesn't work. Cool. And let's do load charge size 0.1f, which might kill everything now. Okay, maybe not. Eh? Why does it not work now? Oh, I didn't save, that's why. No. Huh? How did it work before and now it doesn't? What? I am confused. What now? Doesn't make a whole lot of sense. So it worked when I did this, right? Okay, maybe not. How did it work? Did I do it like that and it worked? Was that it? Oh yeah, that was it. But why? What? Are we maybe not adding leaf mask? Well. Something we can figure out tomorrow. Something is definitely fishy here. So maybe that camera distance is wrong. Oh, I mean, actually, this is kinda, yeah, that is kinda wrong, probably. But regardless of that, so this is like 64 or what? Or is it 128? Okay, so it was at 128, I guess. Oh yeah, okay. Huh. The bigger I go, the better it gets, or what? Or how does that work? Oh no, it doesn't. Never mind, I take it back. Doesn't work. Doesn't work all the way. It's not a magic one. That's bizarre. Okay, yeah, that's something we have to investigate tomorrow. That's not how it should have worked. Huh. Fascinating. Wait, what am I even doing here? Oh wait, I get the distance to the camera. Based on that, I do the lodger. Okay, that makes sense. And then the half extension. No, it still makes sense in my head that this would work, but it doesn't, it seems like. Oh well. Whatever. We will deal with that tomorrow. Let's bring back our beautiful sphere, because why not? So we have like a nice potential screenshot as an end screenshot, even though it's fake, but who cares, right? Ta-da! Let's fix the light maybe a little bit. Is that not the light? Oh no, it's this one. Why is it, why so intense? Turn up the intensity again, maybe a little bit. Range a little bit down. Perfect. Definitely not fake at all. Oh, there's my spotlight. But without shadows it's a little bit hard, right, to see. It's a little bit sad that I don't have shadows yet. Maybe we create a directional light that might help a little bit. Make it a little bit warmer. A little bit less intense. Whatever. Good enough. Good enough for a first screenshot. Let's not talk about the fact that doesn't really work too well with a move that away. With the normals here. But regardless of that, we'll take a screenshot. Because I mean, hey, we got 64 kilometers terrain kind of working. With a lot of caveats that we have to figure out over the next couple of streams. So yeah, there's the floating precision issue. Let's write that down so that I have a list. So that one, and then we have child lot size is behaving opposite of what it should be like. And complex surface threshold seems to be wrong, too aggressive. Yeah, that is as well one thing, which is kind of a trade-off I did for now to get something running to see if it would work, but we currently, yeah, we have like currently everything is one mesh, which we should divide into chunks. And that shouldn't be too big of a deal, because as we have the octrees already, we could, for example, treat all the leaves as chunks. That's a little bit too extreme close up to the player, but in the distance that would work, because in the distance one of those octree nodes is like 1,000 meters or like more, and that would be a perfect size for a chunk. We just need to think of something in the close to mid-range to make it smarter with the chunks. But in the distance that would definitely work, that we just take the leaves. As is. Yeah. Again, we have to come up with something smart here. And then, yeah, the live edit. Live edit on big word scale. Which is an issue, like a whole nother topic. It's not too big, yeah. It's actually kind of surprising for a first try, right? You were all, I mean, I myself as well didn't expect it would work as good as this. I would have expected way more issues. I guess all the back and forth in the last couple of days paid off in the end still. But yeah, it's not really where I wanted to have it, but it's already good to have like a starting point, right? Because now we got it, and we got it on a scale, and now we can iterate on it, make it better, make it more efficient. And it's easier now because we see again something, which is good. And makes it a little bit more enjoyable seeing something. Oh, I mean, I lined up the sun almost with the directional light. Alright. But yeah, it's getting late. I need to take some rest, work tomorrow, and we are back tomorrow at 7:30. I don't think I will do earlier than 7:30 probably. Because of like eating, like having dinner and everything. It's always a little bit stressful already. Thank you. Have a good night yourself, what's up? And everyone else as well, of course. Thank you for joining, as always. We are not so many people, so I will skip the raid. But yeah. This is good progress. We're getting closer to what I would want for the 0.4 version of Onyx. because this is the feature I want to ship with it. All right. Have a great rest of your evening and good night. See you tomorrow. Bye bye.